Our next application has to do with sound as well. In this case, we're going to look at the decibel scale. And the decibel scale is a log scale of the sound intensity. So the decibel scale takes the ratio of the sound intensity to a reference point, which is basically the lowest intensity that human beings can hear. And the decibels is just basically given by this formula, right? It's 10 times the log of that ratio of the sound intensity of what we're looking at compared to the sound intensity of the lowest possible audible sound. Okay, so in this case, I0, which I have here, I naught, is 10 to the minus 16. Okay, that's given here in the description, but so there's the formula for the decibel scale. So let's take a look at example 6. It says if a sound doubles in intensity, by how many decibel units, decibel units does it increase? Okay, so let's just look at these two sounds. Let's say we have the sound 1. Okay, and so we could express its decibel rating by just using the formula. Okay, so we'll just say that the intensity of that first sound is just I1. Okay, I don't know what it is, but I know that I'm going to start at that value. Okay, and so it's I1 over I0, 10 log of I1 over I0. Okay, so that's sound 1. Now the second sound, let's say it has a decibel rating of dB2, and the only thing I really know about it is that it's twice the sound intensity as the first sound. So I'm just going to put that into the formula for the decibel. So we have I2, which is twice I1. Okay, so I'm just going to write it as 2I1 all over I0. Okay, so that would be how we would calculate the decibel rating for the second sound. And what I really am interested in is it says by how many units does the decibel rating increase? So I really want to know what's the difference between dB2 and dB1. Okay. All right, so I'll just plug in my values here that I got. So dB2 is 10 log of 2I1 over I0, right? And I'm going to subtract dB1, which is 10 log of I1 over I0. Okay, I was just noticing something happened here. It should be I0. All right, now let's clean this up a little bit. All right, I can factor out a 10, and then I'll have a difference of logs. So I get 10 log of 2I1 over I0 minus log of I1 over I0. Okay. I have on my parentheses in there. And we know that the difference of logs we can write as a ratio. So what I'm going to do now is write this as 10 log of 2I1 over I0 all over I1 over I0. All right. And then you can see I can cancel a lot of stuff here, right? The I0s and the I1s cancel, and what I end up with is just basically 10 log of 2. Okay, that's something I can calculate, right? I got rid of all those variables. So when I calculate that, I get 3.010 dB. Okay, so that means that when a sound increases, right, when it doubles, when a sound doubles in intensity, it goes up by about 3 dB. Okay, so that's what that's saying. All right, so let's take a look at part B here. It says loud music can measure 110 dB, whereas normal conversation measures at 50 dB. How many times more intense is loud music than normal conversation? Okay. All right, well, we don't know the intensity. We can set up this. Let's go ahead and just use the formula that we know for dB. I know that 110, okay, that's my dB rating of the loud music. So I know that that has to be, oops, hang on a minute, getting ahead of myself here. All right, I need an equal sign in there, right? Because I'm just plugging numbers into the equation. So I know the decibel level of the loud music is 110, and that has to be equal to, oops, again, I'm messing up here. All right, 10 log of, I'm going to call the intensity of the loud music I sub n, m, for music over I0. That's my constant. And then for the conversation, that's 50 dB, and that's equal to 10 log of, and I'll just call it I sub c for conversation over I0. Okay. All right, so let's try and rearrange this and see what we have. We want to really solve for what the intensity levels are, right? So, so let's just we'll divide both sides by 10 here, and so I would get what 11 is equal to the log of I sub m over I0, right? And then I can take both sides. 10 to the both sides. 10 to the 11th is equal to I m over I0, right? All right, so that kind of gives us the intensity level of the music compared to the lowest audible or reference point. All right, and then we can do the same thing over here. We end up with basically 5 is equal to the log of IC over I0, right? And then, so that tells us that 10 to the 5th is equal to IC over I0, okay? Now we have this constant of I0, but I just want to compare, I want to look at the ratio basically of the loud music to normal conversation. So if I take the ratio of these things, if I look at I m over I0 and IC over I0, you can see those I0s will go away. So that just gives us IM over IC. Okay, so we're looking at how many, we want to know how many times more intense it is. So if we do that, then we get 10 to the 11th over 10 to the 5th, which is 10 to the 6th. Okay, so we can say then that, I'm running out of room here to write, but we can say that the loud music is 10 to the 6th times more intense than the conversation, right? So that's 6. Okay, or we could say that it's 6 orders of magnitude. 6 orders of magnitude more intense. Okay, so that's just another way to say the same thing. All right, well, that takes care of the examples in this lecture, and you are ready to begin the discussion questions, and I will see you in class.